Good morning, all. Thank you for attending our webinar on signal conditioners. My name is Robert. I'll be your presenter for today. Let's begin. Okay, here's our agenda for today. These are the topics that we'll go over in this order. First of all, what is a signal conditioner? Then we'll go over some applications for signal conditioners. I'll show you ICP-DOS was established in 1993. Our headquarters is in Hsinchu, Taiwan, and ICP-DOS USA was launched in launched in 2001 to support the North and South American markets.
Muted.
We're ISO 9001, and we're a Microsoft embedded partner. And all of our products are RoHS compliant. Okay, first of all, what is a signal conditioner? A signal conditioner will accept an analog input of one type and usually convert to another one, usually voltage or current being the most popular type. We have modules which handle voltage, milliamps, or current, RTD, thermocouple, and strain gauge inputs. Volts, milliamps, usually converted to 4 to 20 milliamps, RTD, thermocouple, and strain gauge. All of our SG3000 have the following features. They all have three-way isolation between power, input, and output of 1000 volts DC. They're DIN rail mountable, can operate within a temperature range of -25 to 75 degrees C, have input and output connectors on the opposite side so to avoid confusion, and finally are configurable by a switch or dip switches. I'll show you a picture in a little bit. Here's a basic selection guide. Note there are 5 different models, each of which have a different analog input type. The analog input types range from thermocouple, RTD, strain gauge, voltage, and current. And on the bottom, we list the output types available with those specific models. The first model, the SG3011, is our thermocouple input module. This one accepts the thermocouple types listed on the left and the output types listed on the right side. Let's see, with this module, the thermocouple input, for instance, J-type between -40 and 760, if you used a voltage output of 0 to 10 volts, when you have a temperature reading of -40 degrees, you'll get 0 volts, and when you get correspondingly 760 degrees input, you'll get a 10 volt output on the voltage output side in the 0 to 10 volt range. And once you configure the module, it'll have the corresponding either voltage or current output depending on the range. Our RTD module, our SG3013, accept the type of RTDs listed at the bottom, and again put out voltage and current output, or I'm sorry, voltage or current output. And these accept 2, 3, and 4 wire RTD types. Our strain gauge input, the SG3016, provides electrical inputs or allows for electrical inputs of plus or minus 10, 20, 30, 50, and 100 millivolts, and allows for excitation voltages between 1 and 10 volts DC. And the corresponding output types are listed below. Both voltage and current outputs are available. Then comes our SG3071, which is our voltage input module. Usually customers will want to change from a voltage to a current input. So we accept the plus or minus 5 volts, plus or minus 10 volts, 0 to 5, or 0 to 10. Occasionally also, sometimes customers want to go from voltage to voltage. Maybe they have a PLC which has an analog input card which only accepts up to a 5-volt signal. This can be used to scale the voltage input from, say, a plus or minus 10 volt DC signal to a plus or minus 5 volt DC signal. But the typical application is from voltage to current with this module. The same can be said for our current input module, or SG3081. This module accepts a current input and puts out either a voltage or current output. The current input ranges available are 0 to 20 milliamps and 4 to 20 milliamps, and we have various voltage and current output selections. The SG3000 are configured with the dip switches hidden beneath the DIN rail connector. Simply pull out the corresponding orange tabs and it will expose 2 switches. Each model has, a different set of dip switches and different ranges associated with it. This one for the SG3071, in order to set for the plus or minus 10 volt range, you simply set the switch 1 to high, so that would entail 2 and 3 being high, whereas 1, 4, and 5 are low. Then you select the corresponding output range associated with switch 2. The factory default is usually the highest, in this case it'd be plus or minus 10 volts. Some signal conditioner applications. Let's see, I have 3 listed. First of all, it's when the PLC or data acquisition system has an existing I/O card and you have a single input which does not have the correct input type. As an example, if you had a thermocouple input that you needed to add to read temperature to an existing PLC that might have, say, a voltage or current input card only, but not specifically designed to handle a thermocouple. This way you can add one thermocouple to your application, and you can use an existing I/O slot module or remote module. Secondly, the PLC may not have room for an additional I/O module, or you want to consolidate analog input signals to a common module. So for instance, for this one, the system shown at the bottom, all slots are full. If you needed to add, 1, 2, or 3, and you had empty space on one of your other analog input cards, you can simply add this signal to add, say, a thermocouple or any other, RTD or strain gauge input to that analog input card and use that existing module, saving money and saving space. Thirdly, let's see, your sensor may have the wrong voltage or current output type. So as an example, your sensor may put out a 0 to 20 milliamp signal, but your desired input range is actually, say, 4 to 20 milliamps, or you maybe want to convert to a voltage range of 0 to 10 volts output. You can use a signal conditioner to solve this application. Let's see, we have one additional module which is new. This module is specifically designed to be a splitter. Our SG3383 has a single 4 to 20 milliamp input signal, and that 4 to 20 milliamp signal is split into up to 3 different analog outputs. So again, if you have one 4 to 20 milliamp sensor and you want to send the data or share the data with 3 other input devices, you can do that. If you want to do 2, just simply don't use that 3rd channel. Let's see, now moving on, we have our power conditioners. What these do is help to clean up the DC voltage. Say you have a voltage range of between 18 to 36 volts, and you want to produce a nice 24 volt output signal to power your PLC or power a device. With this PW3090-24S, it will provide 24 volt output when you provide an 18 to 36 volt input. We have corresponding modules which put out 12, 5, and an additional one which reads in a 48-volt signal and will put out a 24-volt signal. And these operate with a 83% efficiency. And a simple diagram of how it works is, on the left side it has isolated voltage input, and on the right side it provides a voltage output with the associated voltage. Our DNA100 series are voltage attenuators and current transformers. A typical application that we deal with quite a bit is in the solar industry. We have solar panels, wind farms, and inverters which put out various voltages, usually higher than the plus or minus 10 volts that our devices handle. So we offer the various DN boards listed at the bottom with different voltage ranges that it accepts as the input, and they all put out a plus or minus 10 volt range. Here's a breakdown of our DNA100 series voltage attenuators. We have various different models with different number of channels, different voltage and current ranges, and they're shown here. We offer 3-channel and 8-channel versions, and they have various numbers or various voltage ranges that they accept. Next, we have our current isolation modules, our current input modules. We have these models here listed. The part number breakdown is at the top. The M in the part number means it has a metal case. Without the M, it's just a space or null character. And the number of channels is 3 channels for these. And we have 4-channel versions as well, listed at the bottom. A current input, the current transformer, and finally the input current range. Then finally we have our DNA100 series, which have both the voltage attenuator and current transformer built in. This was developed for a couple of applications, but specifically we have these different variations with a different voltage attenuator and different current transformer ratings. And we have models with and without metal housings. Here's an application picture for one of our 4-channel current transformers. This one has 4 channels, accepts inputs of AC or DC current in the ranges shown under the input current range, and provide a nice plus or minus 10 volt DC or AC signal output. And that can be read in by our M7017 RMS, our I7017R, or any other analog input module, whether by us or any third-party device. A nice product that also is in the signal conditioning category is our SG770. This offers 7 channels of surge protection for any signal from 0 to 30 volts DC, whether it be an analog input signal, it can be an RTD signal, it can be a thermocouple signal, or it can be an RS45 signal. There's 7 channels. Whatever comes in, it cleans up and avoids, say, a lightning surge, and will protect your device on the other side. So for instance, if you have thermocouples on the left side, you can have up to 7 channels, and just wire the corresponding output channel going to your device, and this will provide protection from lightning surge to your PLC. Finally, we have our TMSG4 module. This is the RS45 termination resistor module, which also offers the ability with pull high, pull low resistors to add the bias voltage within your RS45 signal. Everything is switch selectable. There's 15 different termination resistor values, and it will help clean up your RS-485 signal. There's an example at the bottom. If you viewed the RS-485 signal through an oscilloscope and you saw one of the either right side or left side pictures, you can clean up the signal using a TMSG4 by enabling various termination resistor values. And this module, like most of our modules, was DIN rail mountable and has an operating temperature of -25 to 75 degrees C. Here are the two applications for the TMSG4. One acting as a termination resistor at the end of the bus on the RS-485 line. And at the bottom it shows how it can be used to add the bias voltage to an existing RS-485 system. By providing the the 5-volt signal and the pole low to ground, it will help clean up the RS-485 signal. If anyone has any questions, I'll be happy to answer any questions. Let's see, in the meantime, if you have any questions after the fact, if you say forget or need to contact us for any questions, feel free to contact us by phone, our website, or by email, and you can follow us on Facebook, Twitter, and YouTube. Does anyone have any questions? Let's see, I don't see any questions, but if anyone has any questions after this meeting, please feel free to contact us. We'll be happy to answer your questions, and these slides will be posted on the website shortly after the conference if you want to view it later or if you want to refresh your knowledge of our signal conditioners. Thank you for attending.